let me see that how AWS has been came through from 2006, the year of 2006 to all those up to 2017, and what are the what to say they have what are the changes they have been okay, what to say bring into the cloud computing into existence. So let me start that one. So we talk about introduction to AWS. That's the first agenda that we need to understand. When we talk about introduction to AWS, yes, we know that in 2006, Amazon Web Services started to offer IT services to the market in the form of web services. So this is the web service that you're looking right now on the screen, and which is nowadays known as cloud computing. And with this cloud, we need to plan our servers, right? And I can say that we need to plan. Suppose I am in private data center. Yes, sir, we are recording. We are recording this session. So suppose I am in private data center. So in my private data center, what we have to do, we need to plan for a server and other IT infrastructure, which takes up much of time in advance. These services can instantly spin up hundreds of thousands of servers in minutes and deliver results faster. And I'm just talking about AWS because AWS is a service that instantly spin up hundreds of thousands of servers in a minute and deliver results faster. And when we come to this AWS console, so we pay only for what we use and with no upfront expenses and no long-term commitments, which makes AWS cost effective. And today AWS provides a highly reliable, scalable, low-cost infrastructure platform in cloud that powers multitude of businesses in more than 100 countries across the world. So that's the thing. And before getting into the AWS, I want to give you a clear understanding of what is cloud computing is. I can say that, see, being in IT industry, I have been in IT industry, I have gone through all the long and tedious process of procuring new infrastructure for our data centers at one time or another. So suppose I'm purchasing a brand new server. If I'm a private data center, it can take a week. If not, it can take a month to get delivered from its date of ordering. And it is too heavily dependent on a lot of external factors, which most of the time are not in our control. So even if the new server comes in on time, so there is additional burden, right? We need to clear a rack. We need to, clear a space. We need to have a cooling, cabling, and installation software configuration. It's just this keeps on going another mile. So putting the servers and storage on one side, the same can also apply for networking applications and softwares. And I can say that a whole lot of other things that it will take a lot of time to do that, to set up those things. So the thing is, we are fed up with the private data centers. What are the things we have got the problem? So the question is, what if all this wants to change? And the really answer that you'll get is AWS. And what's if tomorrow? So that's why. So when come to AWS, so cloud computing, you could simply jumpstart your business, scale your applications to thousands of servers with all a simple click of button. So maybe it seems like it's a far-fetched, but this happens via AWS and cloud, and that's why. So when we see this, cloud computing has been involved definitely in a lot of years, because cloud computing has been given a lot of huge support for us and become the almost mainstream part of our lives. Everything from storing large amount of data to having burst compute capacity at your fingertips, and also enterprise software applications available on demand anytime, anywhere. Just some of the key benefits that cloud provide today. And that's where the new way of cloud computing is known as Amazon Web Services. That's why this Amazon Web Services is a new way of emerging as a cloud computing provider. And that's why, so today we are here to discuss about Amazon Web Services. So when we talk about Amazon Web Services, so let me go to another important fact about the cloud computing. So let me make the introduction to cloud computing first. So you may thinking that, oh, AWS is separate and cloud computing is separate. It's absolutely not. Cloud computing and AWS both are same, but AWS is a specific cloud vendor we have available in the market, and they are deliver their services as a remote location. They are forwarding the services as a part of remote location. So that's why. So first of all, we need to see the internal concepts of what is there in cloud computing, and we need to understand that how cloud computing is effective for us. And once you understand the raw cloud computing concept, then it is better for you to understand about AWS. So first of all, when we see the cloud computing, we are getting different types of clouds. So how many different types of clouds we have in the market? So I can say we have a private cloud, we have a public cloud, and then we have community cloud, and then we have hybrid cloud. So this is different types of clouds so that we have. And what is these clouds is actually about? When we see this management console can you able to tell me this, what type of cloud this is? Yes, this is absolutely the public cloud. I can say this is a public cloud. AWS comes under public cloud. And what do you mean by that? I can say that public cloud is the one which is everyone comes, like not even AWS. We have Google, Windows Azure, AWS, Rackspace, etc. So all those those are coming under public cloud. And public cloud means anyone can come inside and they can start access the services. So AWS runs in public cloud, so it is very openness. But the problem, what we have in public cloud is very openness, and we have less security in public cloud. That is why we are going for private cloud. And moreover, suppose I'm in AWS right now, so I'm in this AWS Management Console, and I want to launch an instance. So this means I'm going to launch an operating system inside my AWS. So if anyone asks you, suppose I'm launching instance or operating system inside my AWS, what type of network they support by default? That is actually they supports the public cloud, but AWS will give you opportunity to create yourself a private cloud, and that's why this is a private cloud. And I will show you how to make use of public cloud and how to make use of private cloud later in our talk. So before that, we'll understand what is public. So as I told, suppose I'm going for this EC2 instance, and this EC2 instance is a powerful console by AWS where you can able to launch the instance. There's something called, you can able to launch the operating system as you like. So here you can see I have list of a bunch of operating systems. So I'm talking about public cloud. Okay, so I'm giving examples in my AWS as a public cloud. So AWS, as I told, is a public cloud by default. By default, all the settings that what we have in AWS, all the settings that come inside, what is to go outside, everything is connected by a public network. Suppose I'm going to launch this operating system, Microsoft Windows Server 2016. So and I'm just going to select this one, and this is the instance types that AWS gives us. Okay, so when we come to next configuration settings, and when you see this one, step number 3 is asking you configure instance details, where you can able to see. As I told, AWS by default is a public cloud. Yes, this is a public cloud. Why? Because you can see, because it is connected with my default VPC. There is a VPC that's called Virtual Private Cloud. And this virtual private cloud are two types. One is private VPC, one is public VPC. So right now, the VPC that is by default, it is configured and given to me by AWS. But this is something called the public VPC, and that's why I told AWS has created a default network settings for those users coming inside AWS without any investment. There's no upfront investment for any user who comes into AWS because these settings or states that this is a public network. And moreover, suppose I'm launching the instance. So what operating system is selected there? Windows Server 2016. That I'm going to add the storages, and then let me add a security groups. So nothing to worry. I'm going to explain this whole thing step by steps. So I'm going to give some tags, and this will be runs on port number 33. This is the default settings that AWS has given for the particular EC2 instance to launch the operating system. And that's why, so here you can able to see when I'm review and launch, and he's asking me to select a key pair. Let me have a key pair, and let me give a key pair called default, and just let me download the key pair and launch instance. So when I'm launching the instance, you can able to see that my instance is get ready and up and running EC2, and this is launched with my default public network settings. So obviously, as I told, the AWS infrastructure is by default is a public, and you can see here these settings. See, I have not done any changes, right? I have not done any changes inside this management console. What are things available? I have make use of that. So that's why. So you can see this instances start launching here in this specific availability zones and regions, and this is running right. So what do you think about this? I done any changes? Did I type the IP address? No. Did I fix any RAM? No. Did I fix any processor? No. Everything is automated. So everything is keep ready for us, and just get into AWS proper security credentials, and you can able to launch your instance. This is one of the most easiest way to launch an instance, and it is very interesting too. When, suppose if you ask me that how to launch an instance, so in AWS, so actually you can launch instance in private network. You can also launch instance in public network. So later I will come on this one, these two network community and hybrid. These two cloud types of clouds are quite different. I will be coming later on these topics. When, you may ask me that how this instance works. Okay, so since this is running in my public network. See, first of all, in order to understand how this instance works, so we need to understand that because if you have any experience with Cilios-based infrastructure, what is mean by Cilios-based infrastructure? Cilios-based infrastructure means that's something you have worked in your private data center. See, suppose as I launched the instance in the public cloud. What are things that AWS has provided for that particular instance? They provided the private DNS, and they provided private DNS, and they provided private IP address, and then they provided public DNS, and they provided public IP address. So these all things they provided for the particular instance to launch inside my AWS. So you can see here, this is my public IP and this is my private IP. And do you think that where the settings come? This settings is already fetched in the concepts called default VPC, and that's why this instance is still running. So that's why I told AWS by default, it's a public network. And public network means not to break your head on so much of settings and configurations, which is already deployed and already implemented there. And it's easy for it to launch an instance also here. So when you connect this one, so here he'll be asking the key that I downloaded. So where is that key? So I go for that key in my downloads. So we have default.pem, and this is. And actually, that is happens via public key and private key cryptography. You can see this is a cryptographic file. This is launched by my Amazon Web Services, and this is a private key that's what I have in my system, and the public key has been stored in AWS. So suppose I want to launch this word, so I can connect it and just copy this password and just paste it, and you can able to launch it. And this is one of the most easiest one to do that compared to our private data center systems. Let me go to Notepad and paste the password and copy it and just download, remove the stuff file and click. This is, see how easy it is. You find any difficulty of launching any instances? No. Okay. So you can see I have launched one of the most easiest one to launch. This is how the public network is all about. You can able to launch your instance instantly, and you can make use of that. Maybe web server, maybe database server, or maybe mail server, or you may have some application servers. You can make use of that one. Okay. Yeah. So that's why. So this is how the public network is all about. And next, we need to understand about how this public networks process works inside this one. Yeah, guys, as I told, the question answer session will be answered after finishing the session. You will get half an hour timing there. You can post your questions, and then I'm ready to answer those questions. So right now, let session go. And as my colleague Dinesh explained to you that you will be getting those timing to ask the questions. Thanks. Okay, so this all happens so a public network. So comes under this private. What is mean by this private? This is I can say one of the most secure network. I can say private, and we can create a private network by yourself in Amazon Web Services, and we can launch our own cloud. So the private have more secure. It is more, we have more control, and we have more administrative control in the private cloud. Okay, so now the question is how you launch the private cloud. So I can say that this is something quite easy to do that. So if you want to have launch a private cloud, so the private cloud is something, but that is we are configuring our networks by ourselves. See, in order to understand these networks, this is private, this is public, and this is hybrid, this is community cloud. So everything you need to understand, you should have the strong knowledge of IP addressing structure, IPv6, IPv4, and subnetting process. So there's something called CIDR, classless inter-domain routing. And once you have those knowledges, then you can able to create your own type of cloud network inside specific cloud management console. That may be Windows, so that may be Windows Azure, or maybe AWS, or maybe you come for Rackspace OpenStack, or maybe Google Cloud. So that's why. So now we have come to this one, the private. See, obviously, I understand that this public network is so open, and anyone can see. Today, you take one example of Gmail services, and you see how easy to interact with Gmail. So now some guys wants to create an email. What they do, they go for gmail.com, and there is no security restrictions for Gmail, and they can easily create those Gmail mail IDs by their name, and they can access, and they got 15 GB of storages. So do you think it is possible something private? No, private have limited number of access, and that's why. So private is more secure than public. So that's why. So we need to understand the difference between these clouds, private cloud, public cloud. So many people have wrong intention that they're talking about that that the private cloud is a separate network and public cloud is separate network. See, private cloud and public cloud running in the same infrastructure, but the thing is the security rules, the security the security policies for public cloud and private cloud is something different. So that we need to understand between these two. So suppose in case of, if you ask me, let me launch in Linux operating system. So Linux operating system has got the same one. So which I can able to launch it. So suppose I'm going to launch with my Red Hat or Amazon AMI Linux, and let me select it. And this also I'm going to connect it with my default VPC. So this again the same one. So my AWS cloud will give the public IP settings for this instance. That may be Windows or this may be Linux. So let me launch that one. So obviously it runs on port number 22. Later I will be explaining you what is meant by the security groups, and that this will be the most interesting type of, this is called virtual firewall. So what we have in AWS, and this virtual firewall is nothing but, this is, we have a firewall inside our office, right? So inside, so what are things firewall will do? Firewall will check the inbound and outbound routes. Same as this, the security groups will do the same process. He just check the inbound and outbound traffic, and suppose you want to add more traffic, you can go to add more route, and you can add HTTP traffic you want to come inside, and you can select the traffic, and you can then my security groups will allow the traffic to come inside my particular operating system, that may be Linux or Windows. So just now, so I'll be coming back on these security groups later. So just review and launch, and I'm launching with my keypad, and you can see I got launched my Linux, and this also got two IPs, public IP and private IP. This all comes under with my public cloud. So see, this all the settings my AWS will forward for this specific instances to launch it. So those things. So later I'm going to launch this operating system in C2 Linux inside my AWS cloud. So next I'm going to teach you how to create a private cloud. So that will be the thing. And, so I'll be teaching you how to create a private cloud. Let me suppose this is how. Suppose you want to launch a Windows, and you want to launch any Windows or maybe Linux. You can go for these instances, or you can able to launch these types of operating system inside my public network. Okay, so that's why. So let me see that how this private cloud will work. Actually, here the thing is, because in many interviews they're asking you that what is private cloud, what is public cloud? Explain the difference. So many guys, what they see, obviously that the private cloud and public cloud, they are absolutely same, but security boundaries are different. That is absolutely a less explanation. The real explanation is private cloud is something that we need to create by ourselves, and public cloud, that is something already created by vendor. That's something called default. So that is why. So that's the difference between private cloud and public cloud. So we need to, as far as our private organization is concerned, they go for the private cloud. As far as general usage is concerned, they go for the public cloud. So this is how the private cloud and public clouds make some differences. So if I want to create my private cloud, I can able to create it via Amazon VPC. So because VPC, I have added those content in my, I think third day of my speech. So I will be explaining you those things, how to interact with our VPC. And moreover, actually, this community cloud is nothing but, this is, I can say, so let me state this. What is this? This public cloud, private cloud. And this when come to community cloud, this community cloud is something I can say that different organizations used to connect each other. So that comes under community cloud. So different organizations can use to connect each other. That's something we can say community cloud. So see here. Suppose I'm in ZDub Technologies. So there is another company who is running that is near to my office. So both can connect each other. That's something called community cloud. And as far as security policy is concerned, both will get problem. So that's why what we have to do, we need to create a separate security policy for different organizations to connect among themselves. So that's why. So I can say AWS also supports community cloud. And next one is hybrid cloud. When this hybrid cloud is nothing but the hybrid cloud, it's a mix of this types of cloud is a mix of private and public cloud. So this types of cloud is a mix of private and public cloud. And I can say this AWS, as I told already, AWS has mix of private and public cloud. So private and public cloud is a mixing here. So, and this is one of the most toughest network to handle because it has to maintain in heterogeneous networks. Heterogeneous network means, and it's very difficult to troubleshoot. So this is how the hybrid cloud is all about. So this is the different types of clouds, that cloud methods that we can connect, we can make use of the cloud. And I can say that everyone will go for the private cloud more rather than public cloud. And this is based on different situations and different scenario that we are connecting different types of clouds. When next of all, in order to understand the cloud computing, we have to understand their service models. So there are service models that maybe you are familiar with those service models, because these service models are important for us to understand too, because this service models are where the cloud has release times. And those service models, so I will show live examples for those service models, how they are interacted inside the AWS. So we have infrastructure as a service, then we have platform as a service, and then we have software as a service. Do you think that we have not even this, we have anything as a service, database as a service, we have network as a service, identity as a services. After later, there are a lot of services came. So this is the main three services what we have that every cloud vendor used to follow it. So this is something called infrastructure service. Where is that infrastructure service? First of all, let me explain this software as a service. You all people heard about virtualization, right? What is virtualization? Virtualization is nothing but it is a layer between my physical machine and my virtual machine. So because we have different types of virtualizations layers we have available. So let me show you about software as a service. When I go to this management console, this AWS, after I'm just logging in my credentials with proper username and password. And this management console is something I can say this is known as software as a services, and this is MBA software as a services. And this software as a services used to hold almost everything. This used to hold storages. This used to hold the complete infrastructure. They used to hold about the encryption. That used to hold everything. It used to hold runtime libraries and virtualizations. Everything this used to hold. So that's why this software as a services, we are giving so much of importance for him. Whenever user coming inside the a specific console, they have to interact with this software as a services. The software as a services, and this software as a services is the first screen that you are interacting with the users. And that's why not even AWS, other cloud vendors also have a software as a services. What to say that may be created by some programming tools called I can say SOAP, Simple Object Access Protocol, or REST interface, representation state transfer. So that's why this software as a services, this is one best example of this AWS Management Console. And I can say the next one, I can say this comes to the platform as a service. Platform as a service is the one that, suppose as I told, I'm going for EC2 instance. Suppose I'm launching an instance. So this management console is something I can say that this is a platform as a service. What type of operating system that you want to launch? So this comes under platform as a services. And here I can say that AWS has kept the images, different types of images inside this management window that's called Amazon Machine Image. And this is actually a template where all the OS images are kept. And you can select your own desirable operating system from here, and you can start your applications, you can start your services. This is something called platform as a services, and that's why AWS has something called this template as AMI. This is called Amazon Machine Image. And you can see this. We have different types of operating system. You may think that we have less type of operating system. You can choose more operating system in community AMI, where you can able to select any of the operating system you like, and this is 32-bit 64-bit architecture. So, and that's why. So if you next, suppose you ask me where is infrastructure as a service comes into action. Yes, infrastructure, I can say that. Suppose I'm going to launch any operating system like Windows, and next screen that AWS asking you to select on instance type. And this instance type is asking you that what type of, how much of RAM, how much of processor you need to select for the particular instance to start. And that's something comes under instance type. And this is called infrastructure as a service. And infrastructure service, obviously, what is that? Because you need to know specific amount of storage, you need to get specific amount of processor, you need to get specific amount of RAM, right? So AWS gives you wide range of families of instances where you can able to select your own processor, own RAM, and own storages for that particular instance, that particular operating system to launch. Comes under something called infrastructure as a services. And I can say infrastructure as a services is the one which is foremost important. This is the first priority. The second priority for platform as a service, and third priority we can give for software as a services. So this is how these three service models are the backbone for every cloud network to run their services. So that's why, since AWS has given their management support for like this for infrastructure service, platform as a service, and software as a services. So because why I'm giving you these examples, because there are many things are there that about explaining about infrastructure software, but they don't have any specific example for this. But here this is a real-time example for all those. We're choosing instance type, and I'm going for AMI, and I'm going to access those things. So this is how the three service model we got in cloud computing. So this is how we have different types of clouds: private, public, and community and hybrid. And this is one service model: infrastructure service, platform, and software as a services. So as I told, virtualization is the one which is topmost concept for what we have. We have different types of virtualization supports in cloud. So now you people already hear about different types of virtualizations available. I can say virtualization touch we have in platform as a services, and also virtualization touch here in software as a services. So we have different types of virtualizations. One question asked in interview that AWS supports what type of virtualization actually. AWS supports Zen virtualization. So we have different types of virtualization, right? Like we have virtualization called VMware, and then we have Hyper-V, and then virtualizations called Oracle VirtualBox, and then we have Citrix Zen virtualization, and also we have KVM kernel virtual machine. But AWS supports Zen virtualization as a default virtualization for anyone who's coming interacting with this console called Amazon Machine Images, and that's called HVM. That's a virtualization type here, and this is how, because this does not mean that AWS does not support other virtualization support also. They support, but given the complete virtualization support for Zen, so that's a default virtualization platform that AWS has selected. And moreover, we need to understand about the use cases of cloud computing. So that is why we are using for, if suppose your office boss is asking why should we go for cloud computing, and what is the use cases? What are the use cases of cloud computing we have? We have wide range of use cases of cloud computing. Basically, for example, let me put things. Why should I go for cloud computing? First of all, I can say because it has on demand. And next one is, I can say we have network access. We have broad range of network access. And third one, I can say it is shared pool. And fourth one, it supports rapid provisioning. So these are some use cases for the specific cloud for us to have. So first of all, on demand. So actually, in our traditional data centers, what are the things we have seen that? Do you think that you can able to get on demand all the services we have? No. So because cloud computing provides you on demand services. So suppose you want to spin up with many servers, and you can go for on demand. So I can say that in traditional IT data centers, where requesting and obtaining resources for your application used to take weeks, and the same resources can be made available on an on-demand basis in the cloud without requiring any human intervention at all. So that's that because of this, because people like to come into cloud computing. And then we have network access, because one of the key features of any cloud is that all of its resources can be accessed over the internet or network in general. And that's why. And next one, you can see this makes it really easy for end user to access and leverage cloud from heterogeneous devices such as laptop, workstations, mobile phones, and so on. And this is shared pool. What is this meant be? Because see, as I told, we must have experiences all the things what we have in our private data center, right? Because if you're in private data center, if your resources go over committed, and then your compute, storage, and networks are pooled and abstracted together from the end user. This pooling enables the cloud to dynamically provide resources to its end users as when required, without the end user having any knowledge of where their application actually reside, maybe cluster or in rack. So that's why this is shared pool. And this is another use case, I can say, rapid provisioning, because rapid provisioning or elasticity, it is referred as nowadays, because it is the ability of a cloud to scale its resource either horizontally or vertically, scale out or scale up. And this elasticity provides end users with a lot of flexibility and control over the resources and how they get consumed. So this is some use cases. And you may ask me, what is the benefit of using the cloud computing, the fourth one? what are the benefits of cloud computing? I can say first is, yeah, obviously everyone know it's a lower cost, right? It's a lower cost. How it is lower cost, I will explain. And then it supports self-services. You can switch over what are the services you need. No need to run behind the administrator and ask him the permissions. And next one is scale as required. Yeah, because this is scale as required. So the first one is lower cost. See, when you compare the cost expensive in your private data center, see, cloud computing does not, as I told, cloud computing does not have any upfront cost. They does not have any upfront cost. Do you come inside cloud computing with heavy investment? No. And capital expenditure is virtually zero, as the entire necessary infrastructure resource already made available and ready for use by cloud provider. And all the end user has to do is consume these resources and pay only for what they use. This is something called pay-as-you-go model. And AWS, not AWS, other cloud vendors, they used to have lower cost. And what are the main benefit of this one? When it comes to lower cost, this also reduces the overall maintenance cost as well. Because since the organizations now has less hardware to manage, it does not necessarily have to bother about the server, network and storage capacity, or having full-time administrator to manage them. Those things are gone. And another benefit of cloud computing is self-services. Because cloud computing provides simple, centralized, self-service-based model that end user can use to interact. And I can say this interaction can be terms of performing simple tasks such as spinning up new computing resources, added more storages, and such as scheduling resource. This ensures that end user can consume any of the cloud resources as on-demand basis. And this is another important scale is required, because the best part of using cloud is that your backend resources can grow as your application grow. What do you mean by that? This means that you're never lagging behind with your application needs and demands. You are always scaling with your application needs. So this means how much your application go higher, that much of resources your cloud vendor will provide you. Suppose I'm running a private data center. In private data center, do you think that if my applications go very high and my private data center machines will give the resources, proper resources to my application to run? No, my application will be lack of those resources. But in cloud is not something like this. If your application demand is go so high, then your provisioning of cloud will be go along with applications, and application will be running fast and smoothly. This is something called scale as required. This does not have, we have in our private data center. That's why we are, this is the benefits of cloud computing we have. This is the main thing that we have. And also can say that cloud, because this cloud computing is based on internet. And with no internet means there is no cloud computing. And here we can see the large groups of remote servers or network polos, centralized data storages, and online access to computer services resources. That's why today using cloud computing, organizations can use to share computing and resources rather than building, I can say building their own operate their storages and moving infrastructure by their own or improving. And with cloud computing, I can say that users can provision and release resources on demand. Resources can scale up and down automatically. What do you mean by that scale up and down? Suppose I'm going for Amazon EC2. Okay, so let me launch this instance. This instance is already connected. So let me launch it because I have the password with me. Because as I explained to you, what do you mean by scale up or scale down? Scale up means anytime you can go high, anytime you can come down. I'll show a real example here. When I'm connecting here and download remote desktop file and click on this one and give the password. Now you can see the instance type that what we have, or what I have right now, it's something called T2.micro, right? T2.micro. And do you think this instance type has got 1 GB RAM and 1 processor? So this is really running in low infrastructure about certain. So what do you mean by scaling? So you can see, suppose this is my Windows Server 2016 operating system I have launched. And when I go to these properties, and you can see it's showing you one processor and 1 GB RAM. Do you think that this is sufficient for you to running databases or running any backend applications? Those require huge amount of resources? Absolutely not. For that, what we are going to do? That's why what I'm going to do now, I'm going to scaling up this instance. How to do that? So just stop the instance. Okay, so when you stop the instance, so my requirement is gone very high, so I want to have more RAM and more processor support. So what I'm going to do, I'm going to stop the instance. Stopping the instance is the same as that I am shutting down my virtual machine. So this is same as that. So here you can see I have stopped the instances. Yes, so instance is not completely stopped. It will be stopping completely here. So once you stop completely, I'm going to change the instance type. Instance type, instantly I'm going to launch this instance and EC2 instance, and now you can see that it will be added more RAM and more processor support. So this is how this is called scaling. Scaling means, as I told, resources can be scaled up or down automatically depending on the load. So let me do that. Okay, it is completely stopped. When I suppose I want to change instance type, okay, I'm going to change with instance like M. Okay, let me select any of the instance like T2.M4X large. Okay, now you can see my instance type is changed. Now let me switch on the instances. So I'm just switching on the instances, and it will be running in this type of instance type called M4.X large. So that instance type will be that's my preferred instance right now because I have selected that, and it will be opening shortly. So that thing. Okay, so now it is running. So let me connect it back. Okay, so I have the password. So let me connect it back. So I give the password. Now you can see it will go to a higher number of resources. Now go to properties and check it. Go to properties and you can see here I have 16 GB RAM right now. Previously it was how much? 1 GB. Now it is 16 GB. So do you think that how much difference is that? This is something called scaling. Scaling nothing but this is how cloud computing is wonderful platform for us to understand him very closely. Now you can see now my RAM is increased by 16 GB. This is how, as I told, resources can be scaled up or down automatically depending on the load. Depending on my application, I can able to scale up and scale down. And this is how, this is very smooth way of changing instance type. Do you think this is for these types of things this is possible in your private data center? In this private data center, it will take a week or maybe it will take a month to do these types of changes. This is how the cloud computing is a platform, and this is the huge I can say that demanded platform for everyone. And next I can say that resources are accessible over network with proper security. And today AWS has got the top #1 priority because of their security. You may ask one question that how AWS has got top #1 priority. It is clear to understand that AWS will give all the resources via security and compliances. If you find if you ask me again that how I believe this AWS is really secure, I will show one URL so where you can go there and you can able to see that how AWS is really secure. So go to this HTTP and just type AWS Amazon and go for this URL security. And once you get it, it's like AWS Cloud Security. And here you can see when I go to compliances, you can see because AWS is given the assurance program. What is mean by this assurance program? Because this assurance program tells that AWS is really secure. AWS is really secure. You can see AWS has got certification attestations, and AWS has got laws, regulations, and privacy, and it's got the alignments and frameworks. This all the vendors tells us that AWS is really secure. And any interview that people will ask you, can you able to explain how AWS is really secure? You can say AWS has got assurance program from different attacks. You can use 5 or 6 names from here, like FedRAMP or HIPAA, or you can go for IS4, or you can go for Department of Defenses. These all organizations gives security attestations for AWS that this is really secure and safe. So we can believe that AWS is really secure compared to other cloud vendors. And this much of certifications we don't have in our private data center also. That's why. So that's why AWS security is all about. And because they got the certification of finance, healthcare, government, and more. And this is how this proves that AWS is really secure. That's why, as I told, this is benefit. Cloud computing. Next, I can say that cloud service providers like AWS or maybe Windows Azure, they are using pay-as-you-go model where users are changed based on the types of resource per usages. Here you can see that suppose I'm going for this one, and I'm charged per hour. So per hour, what you say, they're going to put the bill. This is same as you are using electricity in your home, right? So how much electricity you're going to consume, end of the month you're going to get that much of bill. This is same as that. This pay-as-you-go model, same as that. How much you're going to consume the resources, that much they're going to pay to you. They're going to you're going to pay to them. This is something called pay-as-you-go model. So that's why cloud is most effective and at all cost, lower cost. So it is not something that you always go for pay-as-you-go model. We have something called non-pay-as-you-go model also in the cloud computing. That's something called spot instances or reserve instances or scheduled instances, something like this. I'll be discussing those things later in our sessions. And I can say that I can say more on cloud computing, that it is safe, as I told, is reliable, and this is cost effective. And I can say I can say a benefit of cloud is reliable. So that's the important thing that we have to understand about him. It's reliability. Yes, what is reliability? Because cloud is reliable, scalable, high availability, and it have load balancers. So see, because in cloud computing, not all things are visible to us. Not all things are visible. Many people will say that cloud is how cloud will do load balance. It is something transparent to the user, and how cloud do the scalability process. There's something transparent to user. But AWS is the only cloud vendor has given scalability that you can able to realize by yourself by something called auto scaling. That option we have here, auto scaling, and I have added the auto scaling options in later days of our session. So I'll be teaching you that how auto scale process works and how it is more effective. And this is how the auto scaling comes into existence. When it comes to reliability process, because a cloud computing platform provides much more managed, reliable, and consistent services that in-house IT infrastructure. It guarantees 24/7 and 365 days of services. If any of the server fails, then hosted applications and services can easily be transferred to any of the available servers. This is something very, very different. When we come to private data center, how many days it will take if someone's server fails, and what are the data stored in that server, and to switch over to next server, it will take at least a month or week. Then the administrator head will going to break. But here is not something like this. That's the reliability. Reliability means, as I told, when server fails in cloud, all the applications and services are easily transferred to any of the available servers. This is how the cloud computing is. This concept shows this is really reliable. And next one, I can say that we have unlimited number of capacity. That's the important thing that we need to understand, because it supports unlimited storage. This storage is a very, very vital topic for us, because today we are breaking our expenses on storages. We are fed up of traditional storages, right? We are fed up of traditional storage like SAN storage, NASA storage, iSCSI, and then NFS. All these types of storages has some limitations of capacity. But Amazon Web Services has got one storage called Amazon S3, and this is absolutely a dynamic, wonderful storage. This is something called unlimited number of storages you can able to put inside this one. And Amazon S3 is a first cloud vendor serviced by AWS. This is something called object storage. And object storage means it holds unlimited number of, virtually unlimited number of storages, and there is 0% capacity for this types of storages available we have in AWS. That's why AWS, because that's where people will leave other cloud vendors come here, because AWS is reliable. AWS give unlimited number of storages, and AWS is the one who give two types of storages: short-term storage and long-term storage. And Amazon S3 is a storage that have unlimited number of capacity. Virtually, you can put any number of data inside that, and he never say, "Oh, I am loaded." So, in case of your traditional data center systems, they have always they have limited number of capacity, and they say sometimes they are overloaded. So that is why this, as I told, it have unlimited of storages, because cloud computing provides almost unlimited storage capacity. And this means we need not to worry about running out of storage spaces or increase our current storage spaces availability. We can access as much or little as we need it. This is one of the most benefits of cloud computing. And also, I can say that it supports backup and recovery. So because we are always breaking head on this also, backup and recovery of your data. And backup and recovery data is, it is a small process, do you think? It is not, because disaster can come anytime. Because storing data in cloud, because when you're storing data in cloud, backing up and restoring the same is relatively easier than storing it on physical device. And the cloud service provider like AWS has enough technology to recover your data, so there is a convenience for recovering your data anytime. So that is why backup and recovery is there. And next advantage, I can say that easy access of information. Yeah, that's the thing, because you will not find any difficulty of accessing any of the information that you have, because see, once you register yourself in cloud, you can access your account from anywhere in the globally. Globally, you can able to access and provide just you need to have a single piece of internet connection at your point. There are various storages and security facilities that we have, what type of account you have chosen. And that is why this is the benefit of cloud computing. So I can say, see, as far as I am concerned, I can say these all advantages of cloud computing. But there is a disadvantage also cloud computing we have. So that disadvantage is because because many people will say that, oh, there is no disadvantage in the cloud. We have disadvantage in everything, right? So I will discuss the disadvantage things also in the cloud. So what are the disadvantages in the cloud? That really, guys, you will be wonder that what a disadvantage we had cloud. So see, right now I have speak all advantages process inside the cloud, but there is a disadvantage. First disadvantage, I can say that let me state that first one. Okay, so the first disadvantage, what is that? Because I can say, I will not say that disadvantage will be. So first is one security issue. Yes, because we can say security issue we have in cloud. Because I'm leaving my private data center, I'm going to cloud. This means what? So I will be closely watching the particular cloud vendor, they have security issue or not. If I go and ask AWS what type of security you have, but as I told, they will open that. I have opened that console, right? AWS this management, AWS.amazon.com/security. They have registered with all the compliances. We can say that we have a security issue. What type of security issue they may have? But I'm not telling 100% they have security issue, but they may have security issue. Because it comes like that, because security is a major issue in cloud computing, because the cloud service provider implement the best security standards and industry certifications that I shown you. But however, storing data and important files to external service provider always bears to risk. Suppose I'm storing my data with AWS, I think myself that, oh, my data is secure, but I don't know that AWS is really maintaining my data. Maybe they are connected with any third-party vendors. They may be connected with the third-party vendors that I really don't know. So that's why that really I don't know that that they are storing my data themselves, or whether they are storing my data with some other vendors. So that's some kind of security issue. So I cannot believe any cloud vendor that my data is secure, because I may have problem with the security, because I am registered with AWS. So I think that my AWS will be maintaining my data. But if AWS connected with any other cloud third-party vendors, that I am unaware of them, that's a security issue. And I can say that AWS cloud infrastructure is designed to be most flexible and secure cloud network. It provides scalable and highly reliable platform that enables users to deploy applications, data quickly and securely. But right now I can say AWS is really secure. And yeah, because you have asked me a question that AWS given by various vendors. Yes, because AWS not even AWS. Other cloud vendors also connected with other companies, third-party companies. So they're giving access rights to them to store our data. But I can say that AWS has openly given a statement that they are registered with this much of compliances. So attestations they got. So everyone has to believe him. He is really secure. So I can say that yes, they are really secure. But security issue has not came up to this. And you must, because see, actually we are end user. Okay, so we have some limitations of accessing we have limitations to go in security. In AWS, what type of security they give? They give security like AMS, HSM, and they give some cryptography security. Like this, they will give. But one thing, just remember that when come to technical issues, so that's I'm going to talk about here. Come to technical issues, because as a cloud service provider, it offers services to a number of clients each day, right? Sometimes the system can have some serious issue leading to business processes temporarily being suspended, and additionally, if the internet connections become offline, then we will not able to access any of application server data in the cloud. That's a technical issue. So I'm not in that's a 100% disadvantage, but maybe it can be a 100% of disadvantage, maybe of technical issues. So I guess next one is, yeah. So as you asked me, suppose I am in AWS cloud. I have registered my network with AWS cloud. So after 6 months of time, I'm going to switch over another cloud provider. That's something difficult. So that's why as I told, that's why I'm going to tell that it's not easy to switch service provider. Yeah, because suppose I don't want AWS. I'm going for Windows Azure. It is something is not possible. Not possible means something is very difficult to do that, because cloud service provider promises vendors that the cloud is so flexible to use and integrated. But however, switching cloud, so I can say service is not easy, and most organizations may find it difficult to host and integrate current cloud application to another platform. Like interoperability and support issues may arise, such as application developed on Linux platform may not work properly on Microsoft.NET. This is exactly the same one as this. So that is why switching one cloud vendor to next is something I can say it's not easy to do that. And next problem, I can say that incomplete of data deletion. Incomplete of data deletion. Because I can say that suppose I have deleted my data inside AWS, but I can say that my data is not completely deleted. I can assume that my data is not completely deleted in AWS. Maybe my data is not deleted, but for the sake of showing my data is deleted in front of my eyes, this does not mean that my data is deleted. So I can say incomplete data deletion may be in the cloud, but every cloud vendor promises that once you delete your data, it is deleted. But I can say that maybe we have incompletion of data deletion in the cloud, and that gives us a really what do you say, creating a lot of doubts in your mind that my data is really deleted from the AWS. So that's the thing. So once you think all those things, and we can get some, these are some disadvantages of the cloud, what we have in the network. So apart from this, cloud is absolutely fantastic, and we can go global in minutes. That's the thing, because organizations can deploy multiple applications to multiple locations across the world just a few clicks. And this allows organizations to provide redundancy across the globe and deliver lower latency and better experiences and to the end user at minimal cost. So going global used to something only the largest enterprises could afford to do, but cloud computing decrease this ability and make it possible for any organizations to connect within global in minutes. And that is why this is the one which is what we have, the concepts that what we have in cloud computing. I hope up to this you understand. So next I'm going to teach you about AWS global infrastructure, and we're going to talk about it because it is important to understand the global infrastructure process. When come to understand this AWS global infrastructure, because AWS global infrastructure, you may know or may not be know, AWS global infrastructure consists of regions and availability zones, right? So you may think that what is regions and availability zones. I can say that because when I go to AWS Management Console, and when I clicking on this options, when I click on this one, you can see there is a regions, list of regions, and inside that region we have availability zone. This something comes under AWS architectures and components, also known as AWS global infrastructure. You know that we know that AWS is spread out globally and has its presence across United States, Europe, Asia, Australia, India, and this one. And still AWS going to launch more regions. So each of these areas is termed as a region. So AWS currently have about more than 13 regions, and each containing multiple data centers within themselves. So I'm telling that multiple data centers called availability zone. And that I will show availability zone here. Suppose I'm in United States North Virginia region. Okay. So what is availability zone here? You can see I can say 6 availability zone is running inside that particular region, and you can see this is the United States North Virginia. It goes 6 availability zone. When I go to any other region apart from that North Virginia, I will get more availability zone, maybe less. And just we have to remember that sorry, AWS does not have same availability zone for all regions. Okay, in order to check the AWS global infrastructure, go to google.com and just go to this one. You may find more information about AWS global infrastructure. And when you go here, you can able to see that in this map, the AWS clearly tells you that what are the regions they have started and how many availability zones they have. And you can see here there's written 3, 2, and 3 and something. Inside that region, the number of availability zone we have. And just remember, AWS have total 44 availability zones across all regions, totally all regions, and they have 16 16 geographic regions across the world, and more regions are ready to come, like from China, France, Hong Kong, Sweden, and also more regions are ready to come, and they're still increasing the infrastructure across the globe. And just remember, AWS has one more region called AWS US Government. So this is government cloud, AWS. So this is specifically not listed when I'm coming here, because that region is available only for United States government people can come inside. No other peoples can come inside that region. That something comes under AWS called AWS Government US, and they still started increase their regions across different countries. And this is how AWS global infrastructure is all about. And you need to understand about the particular cloud vendor infrastructure because how they're spread across different regions, and they are still constructing they're expanding their networks across different countries. So here this availability zone, and this is how AWS global infrastructure is very important to understand. First of all, we need to understand what is this actually regions and availability zones. As I told, not all the regions does have same level of availability zone. Just remember, suppose I am going for this region, United States, Asia Pacific, Mumbai region. Okay, so I went to Asia Mumbai region. Do you think that it has 6 availability zone? No, it has only 2 availability zone. But AWS is still working under the construction to increase the number of availability zones across different countries. Then come to this United West Oregon region, I can say that I have less availability zone, maybe 4 or 5 or maybe 3. So this is how AWS is maintaining not the same level of availability zone they are maintaining inside the specific region. And just remember that because each region split up into 1 or more availability zone, okay, and availability zone is isolated location inside a region, and availability zone with particular region connected to another availability zone via low latency links. So this US West 2A, which is running inside Oregon region, it is connected with low latency link with US West 2B, and it's connected with low latency US West 2C. So this is how because what is availability zone? Ideally, they are made up of 1 or more physical data center that host AWS services on them, just as with regions. And even availability zone have corresponding codes to identify them, like US West 2A, 2B, and 2C. Generally, they are followed by the region name. And that's why, see, availability zone are very important from design and deployment point of view. So being data centers, they are more capable of failure and downtime. So it is always good practice to distribute your resources across multiple availability zone and design your application such that they can remain available even one availability zone goes completely offline. So that is why this availability zone. And just remember this. Just remember, but in AWS, not all services have comes under regions and availability zone. There are few services. Those services in AWS, they does not have regions and any availability zone. For example, when I go to Amazon S3 does not have any regions, nor that does not have any availability zone. When I click on this one, they see there is no regions. So this is how, and when go to Amazon Route 53, it also does not have region. This is regionless. This service is regionless. You can see there is no regions for him. And when come to Amazon, this one, Identity and Access Management, this also regionless. So this 3 management console of AWS is absolutely regionless, and that's why. So you can see this is a regionless. And you may ask question why they are regionless. I can say why they are regionless because throughout the AWS console we are accessing that resources. Like Amazon S3 is not even storage for user. It's a durable target storage for other AWS components like Amazon CloudWatch, like Elastic MapReduce. And then it's a durable target storage for RDS, DynamoDB, Elasticache, Redshift. And that's why it is regionless. And when it comes to Amazon Route 53, the Amazon Route 53 is a global DNS provider for Amazon Web Services. And that's why it is also regionless. And this is used for domain registration. And this is Identity Access Management. This is another console, absolutely free for you. And there is no cost. No per hour cost will be applied on this Identity Access Management. This is also regionless because globally we are going to share with AWS accounts just same as Active Directory what we have in our private data center running in Windows servers. So this is how, apart from these 3 services, other services that comes under regions and availability zones. And this is how, and that's why important things in many interviews they're asking what are the services in AWS does not have regions and availability zones. So now I hope you got the answer. 3, Amazon S3 and Amazon Route 53 and Identity and Access Management, they never comes under regions and availability zones. One question asked here, suppose I am launching here, suppose I am in USS 2A. Okay, so suppose I launched the one instance like this, and I am in this region. Which region? I am in Oregon region. It is possible for me to suppose I am changing my region to next. Suppose I am changing my region to Asia Pacific Mumbai. So what will happen? Suppose I'm changing my region. See, AWS tells clearly to end user that they will not take responsibility of replicate the data from one region to next. they will not replicate your data from one region to next, because that user have to do by himself. So that's why, suppose I'm clicking Asia Pacific Mumbai, you can see there is nothing running here. See, there is nothing running here. So I have launched my instance in this United States, East North Virginia, or maybe some other region, and that data is not replicated to another region. How it happens? Because AWS, as I told, AWS will not able to take responsibility of replicate your data from one region to next. That's something we have to do by ourselves. And just remember, this all, see, one question may be asked in the interview, that how it is possible for you to select, you are going to switch back from one region to the next, how it is possible? Suppose I am right now, I am United East North Virginia region. How suddenly you are changing yourself to ACS Mumbai? How suddenly you are changing? This is only possible because of edge locations. There is edge locations is running between these regions. Via that edge location, it is possible for me to switch back from one region to next. That edge location is something transparent to user. And if we want to understand about edge locations more, you need to come for Amazon Management Tools called Amazon Cloud Trial, and it will give you about CDN network, as content delivery network, and thus will give you the complete information of data transfer between one region to next. So right now I am in Unit North Virginia. So via edge locations, it is possible for me to switch over one region to next. This is how the edge locations. And this edge locations, when you see map in the AWS Global Infrastructure, when you type edge locations, it will be showing you the edge locations they have created between different regions. That's why AWS is, that's why it is possible for any user to switch over one region to next. I hope you understand this one. And when come to AWS Global Infrastructure, as I told, it consists of regions. And availability zone. So I hope you understand. And just remember that AWS regions and availability zone is the first step to understand him more better, because those people have what is less knowledge of regions and availability zones. It is very difficult for them to understand complete infrastructure, because today AWS serves over 1 million active users in more than 190 countries, and it continues to expand its global infrastructure steadily to help organizations to achieve low latency and higher performance for their business needs. And that's why AWS provides high available technology infrastructure platform with multiple locations worldwide. And these locations, that's why I told you, this is regions and availability zones. And just remember that when we talk about this availability zone concept, because since, as I told, each region is so independent from each other, because you may ask one question, why AWS has designed such like that? Because each region is completely independent and designed to be completely isolated from other regions, because this achieves the greatest possible of fault tolerance and stability. Because each availability zone is also isolated, but the availability zone in the region are connected through low latency links, right? So that's why that's why the availability zone that you're seeing right now, they are connected with low latency links, and they're more stable. And you can see that this. Okay, so you may ask one question here, that what is the question? How many regions are available? Yeah, that's why I told we have total 16 regions are available, and more regions are coming and gonna be added, and we can have 44. Yeah, so that's absolutely right. Mr. Rahul had given answers that 16 regions and 44 availability zones. And when talk about more availability zones are physically separated within a typical metropolitan region that are located in lower risk floodplains. What do you mean by that? Lower risk floodplains, any disaster come, natural disaster, so it will not affect you so much, because each availability zones are redundantly connected with multiple tier 1 transit provider. This is connected with multiple tier. That's why AWS has placed resources in separate availability zones, because it will protect your website or application from service disruption impacting a single location. That's why AWS Global Infrastructure is the one. And the services like RDS or DynamoDB or Redshift, they want to take advantages of multiple availability zones. one question may be asked, what is mean by multiple availability zones? I can simply say that, see, you can achieve high availability by deploying your application across multiple availability zones. Then, that's why redundant instances for each type. For example, we have web applications and databases. Like these types of services, they need to be placed in multiple availability zones. That's why AWS has given opportunity for every user to place their services like databases in multiple availability zones. In case of RDS or DynamoDB or Redshift. Why this is because in problems constraints, they will find a multi-site solution. And just the main goal is to have independent copy of each application stack in 2 or more availability zones. That is why this, that's why this multiple availability zone is the one which is most highly and more secure type of options we have available for databases. When it comes to EC2 instances, I can say that each and every, I can say what are the instances is running right now. They can be part of a single availability zone. They cannot be part of a multiple availability zone. And that is why, so single availability zone, multiple availability zone. So AWS know that which of the applications need more support, more infrastructure supports. That's why AWS has designed multiple availability zone for databases. So that's why AWS global infrastructure is all about. And also we need to understand that this global infrastructure is the one which is defined by different things. Because when it comes to security, when it comes to global infrastructure, maybe compute, everything is, actually this is wonderful here because everything is decentralized. So that is why we are using AWS as a native one, as a native cloud vendor for us. And moreover, suppose I am connecting my AWS into CLI. You know what is the CLI? Command line interface. So you can operate this AWS Management Console in three concepts. So first, you can able to access AWS via, just now I'm accessing AWS Management Console. You can able to access AWS via AWS CLI, command line interface. And third one, you can able to access via SDK, that is called Software Development Kit. So if you go for the third option, obviously you should have a great knowledge of programming like Python, Node.js, or maybe AngularJS, or maybe .NET, any of those programming languages you need to have, and you can go for Software Development Kit. If you're coming from a background of AWS with Linux, you can come for AWS CLI. And you are a fresher, you don't have any experience in the cloud, means you can come for this Management Console and you can access it without any prior knowledge of any of the programmings or maybe any of the knowledge of operating systems. Okay, in between I got a lot of questions. So what is it? First question asked, AMI cannot be downloaded like cloud. Yeah, that's totally. Okay, yes, it's global. So that is why. So that's why as I told this, it is important to understand about. See, this Management Console you can access in 3 ways. That's why as I told, like you can access via AWS. But this is those users coming without any knowledge of Linux or Windows or maybe from any command line interface. And when it comes to this AWS CLI, if you have knowledge of CLI like PowerShell or we have any terminal knowledge, you can able to connect with AWS CLI. And if you have knowledge of SDK, Software Development Kit, I can say that you can able to, you're the most welcome person in AWS. Suppose you have this knowledge of Software Development Kit, and you can rock your AWS consoles with scripting, with a lot of tools are available. So this is how AWS accessible methods. So I will teach you how to access this one. I will give one examples how this. This you can able to access with. So right now the method that we are working with, this is called AWS Management Console, and later in our second day or third day class, we'll be showing you how to work with CLI and how to work with Software Development Kit. So that gives you real understanding of how this AWS is really what do you say, because sometimes AWS will test you so badly because of their different accessing methods. So right now, this console is very easy for everyone to access. This console very easy, and this console is a user-friendly console. Since Amazon Web Services is based on Linux, okay, this console is based on Linux because everything represented is a concept of Linux. But AWS somehow managed to give this console easy way to access, and that's why it's very easy to access. I make sure that if you go for any other cloud vendor other than AWS, like Windows Azure, or maybe you go for Google Cloud, you need to have at least you need to have a 10 to 20, or I can say 20-25% of knowledge of programming, and you should have at least 15 to 10% knowledge in OS. But seriously, when come to Amazon Web Services, when come to accessing AWS graphically, it is very easy for anyone to stick with him. For example, you can see this. Suppose I'm using Amazon EC2, Elastic Compute Cloud. And this is, just remember, this is the most powerful console that AWS have. And I can say, like Amazon EC2, no other cloud vendor can match their technology like Amazon EC2, because Amazon EC2 is one of the most wonderful compute store, because Amazon EC2 whole bus manipulation capacity it have to launch an instance, to take snapshots, and to, or I can say, to this is EC2 you can able to manage by CLI, and it have a lot of high level options, elastic load balancing. It supports storages. It supports different types of auto scaling options. So that's why this EC2 is one of the most powerful services we have. It's just the same as Amazon S3, and that's why. So Amazon EC2. So that's why. So you can able to access, you can able to manage your AWS in different levels, and in organization point of view, which level they are expecting. Most of the time, they will be expecting about CLI or SDK. So because if you get trained in CLI and SDK, so I can say you are the most demanded one for AWS, because it is because CLI, those guys are working in CLI, they are real administrator, because they have tested so toughly. Because that's why if people are coming from different Linux background, so because they may go for CLI, because CLI is what are the things possible we have in CLI. It is not something possible in Management Console. This is not possible here. So CLI is more flexible, and everything is command line. So that is why it is the most respective one for us to work with CLI. So I will be teaching you that how to work with CLI and how to make use of CLI. I will show you 3 or 4 examples. I will be showing you examples of how to work with CLI, and how to work with Management Console and Software Development Kit. Later, I will be showing how to launch a Linux operating system in CLI, and later I will show how to launch Windows operating system in CLI. Okay, I hope up to this you understand, and it's time for us to take your questions, and it's time for me to answer. So okay, so yes, you can you can go ahead with your questions, and I'm ready to answer. Okay, you can post your questions right now. So this is okay. What the first question is, when we log on to AWS, how do we know that which availability zone is connected? Obviously, you have logged on to AWS, and suppose I have logged on with David account, and you want to check your availability zone. There is a lot of ways to do that. You can see which availability zone means for something that you are going to select by yourself, or AWS will select by themselves. For example, suppose your boss is planning to launch an instance. Suppose if they want to launch an operating system, go to launch. Suppose I'm launching Windows Server 2016. Click next, and here you can see this is how you can select your own availability zone from here. Because since you are connected with this specific region, and this specific region contains 6 availability zones by default, so select it anyone as you like. But remember, if you are not selecting any availability zone from here, AWS will select its own availability zone by himself. So that is why no preferences. Suppose you want to select any availability zone, you can select it, and you can able to launch the instances. Once you launch the instances, for example, you go to EC2 and you can able to see here the instance is running, and this is the availability zone. This is very easy for you to select. You can check the availability zone from here, or select your own availability zone. But just remember, once you selected, suppose you not selected your availability zone, after that you want to change availability zone, that's something not possible. Okay, next question. Next question is next question, can we know about different edge locations regions? See, edge locations and all is transparent to user, as I told. But if you are more interested to know about edge locations, then you need to go for Amazon CloudFront and CDN, Content Delivery Network. And there only, because there only I will able to show you the edge location, real power of edge location. So right now we have minimize of time, so that's why CloudFront is the best option. I'm going to prolong. If you want to know about CloudFront, you can personally you can chat with me. So my colleague Dinesh will send you those informations. Because why? Because I'm telling, because configuring CloudFront, because it will take some time for us understanding him. So that's why. So but you can go for CloudFront and you can know the difference about edge location. Otherwise, you go for AWS Global Infrastructure in Google.com. You can go, you can type in Google and it will show the global how this edge locations is really processed. See, edge locations, that's something running default. Suppose you want to make change, as specified, you have to go for CloudFront. Okay, next question. While changing instance type, we do lose data? No. While changing instance type, you will never lose your data. You can upgrade, just like but just remember, if you want to change instance type, you need to switch off your instance. You need to stop your instance. Okay, so as I told, you need to stop the instance and then you need to go for instance type. Your data will be remain forever. What are things you installed, what are things already running, everything will be remain forever. So just like you are changing the instance, this is scaling. This I told you. Suppose I don't want this one, so suppose I'm going to stop the instance. See, stopping the instance only you can able to do that. Otherwise, you cannot able to change the instance type. So that's the thing, and your data will not be get affected. Okay, let me take next question. S3 is a global. Yes. Then how replicate data? Yeah, that's very simple. You can able to see here. When I go to services, we go Amazon S3. See, many people have think Amazon S3 in different way. Amazon S3 is global-less, is a regionless. I can accept that, but just remember that it is regionless means it is your responsibility to take what is transferring data from one region to next region. How to do that? Here, one example I'll show you. When you create a bucket, so let me create a bucket and create it. Okay, so I'm created in bucket. So I have two buckets. So one bucket is running in my unit is North Virginia, another bucket in my Asia Pacific Mumbai, and that's why when you click on this one, click on this bucket, and you can see we have management. We can go to properties. We have something called cross-region replication. And when you click on cross-region replication, you can able to replicate your Amazon S3 bucket from one region to next. This is how. And in order to cross-region replication to work, your versioning should be enabled. Okay, you have to enable your versioning. And what is keeping multiple versions of data in single bucket. And you can see it's asking you whole bucket, and this is the source bucket, and what type of storage you need. And it's asking which region you want to transfer. So select the region and transfer it. This is how you do cross-region replication, and you can able to transfer data from from data S3 from one region to next. Okay, let I take another question. How can I change my instance type when instance is running? I'm sorry to say that when instance is running, you cannot able to change instance type. You need to stop the instance and you need to change it. As I told, this instance is stop. Go to instance settings and change instance type. Okay. So here, so while it's stopping this instance, only you can do those changes. While running the instance, you cannot able to do that. That AWS itself does not have those options. So you can see as stop, I'm going to select this one, and it will replace T2 micro with M4.16x large family. So you have to stop the instance and you need to start the instance. So it will be starting from that instance types. Okay, next question. When you say easy access of information, simple internet, can we access AWS console through mobile? Obviously, you can able to launch. That's why I told AWS is a heterogeneous network. You can able to connect with your laptop. You can able to connect with your mobile. You can connect with your desktop. Anyway, internet is a general network. Okay, for mobile is separate, for desktop is separate, for laptop is separate, for iPod is separate. There is no such things. Internet is separate. You can able to access this. You can able to connect AWS using any of those devices. Next, where we can troubleshoot instance goes down. See, instance goes down. What is the reason for instance goes down? First, we need to understand. See, this is a cloud network. Okay, this is not our private data center network. That operating system running right now fine, and tomorrow morning when I'm coming, it is got corrupted. It is not something like this. See, we have something called share responsibility model. Share responsibility model is nothing but some responsibility has to taken by you, some responsibility taken by AWS. Let us show that model here right now. When you go to this AWS share responsibility model, this is the model that AWS releases. You can able to see clearly that what are the I can see here what are the responsibility you have to take, what are the responsibility AWS will take. AWS will take responsibility, like you can see cloud, compute, storage, database, networking, and regions and available edge location. This is the responsibility taken by cloud. And what are the responsibility has to be taken by you, like customer data platforms and operating systems and firewall configurations, identity access management and encryptions and network traffic. Everything you have to maintain. So do you think that troubleshooting goes something by you? No, troubleshooting has to be taken control by AWS. So something's not being. But I done some mistake by myself by human error. Suppose I have deleted my instance. I am asking AWS to bring my instance back. That is not something possible, because that error comes to me. This is how share responsibility model gives you complete understanding. What are the things you have to take care, what are the things AWS will maintain. But you done something wrong here, you are responsible. So they will not get responsible for that. So like this, if you done something wrong, you are responsible. So you can able to clearly understand about the share responsibility model. Okay, go for next question. What about high availability and SLA between vendor and client? I can say that, see, we had two types of models in cloud. Okay, so I'm not telling that 100% we have to go for cloud. We have two types of models in the cloud. So first model is something called all-in cloud, and second model is called hybrid cloud. So what do you mean by this? Actually, high availability is available in both between vendor and client. So you can see all-in cloud means I'm going to vanish my private data center. I'm going to move with AWS. When it comes to hybrid cloud, 50% data stored in my private data center and 50% data will be stored in my AWS. So that is called hybrid cloud. So it is depends on what type of cloud, what type of model you are going to adapt before you are going to move to cloud. So high availability is achieved based on this. And straight away, I'm going to vanish my private data center. I'm going to inside everything cloud. That is very rare, right? In this case, so hybrid cloud tells you that 50%. Suppose in most of the companies today, they are moving their networks via projects. Okay, so to fulfill the project needs, they're purchasing the infrastructure from the cloud vendor. So they are following hybrid cloud model. But all-in cloud models, you are free to connect all-in cloud because obviously it is the one, just remove your private data center and cloud. So high availability is based on these models. Okay, next question. Okay, so next question. If you close some web services that we deleted all the information in AWS and we get back to storage after 1 years we requested. See, actually, as I told that, as far as this share responsibility model is concerned, if anything that AWS has done something mistake, then they are responsible. But apart from this model, if you done anything mistake by you are going to be responsible for that. And if you delete your data by yourself and ask AWS, give me data, then they will not be able to recover you those things. This is